Sensation and perception. Basic questions we're going to be looking at in this lecture. Generally, and I raised this question in lecture 1, how do we piece together our subjective perception of the world out there? That's a basic question. And we kind of covered it by saying that sensation and perception combined provide us with what we hope is a reasonably accurate, albeit subjective, rendering of the world out there. And we're going to be talking more specifically today about how this happens and some of the things that can influence our perception. So last lecture we talked about the sensation side of things, that is the visual apparatus and how it works, structures and functions. And this lecture is pertaining to perception. All right, so specifically we're going to look at what a perceptual hypothesis is, what feature detection is, how does it relate to the processing of visual information, what are top-down and bottom-up processing, what are perceptual constancies, and then what's a perceptual set, and how do context and culture affect perception. All right, so again, we made the point last time that our perception of the world is subjective. Visual illusions are a good way to illustrate that. But there's this disconnect between our perception of the thing out there and the actual physical properties of the thing. So really, perception is a guessing game. And we're pretty good guessers. We're pretty good at guessing and knowing what's out there based on the stimulation of our sensory apparatus and are putting that information together, which is the role of our perceptual processes. So in the end, though, it's a guessing game. We're guessing about what stimulus out there is most likely responsible for the image that's impinging on our retina. So it's a guessing game. And these guesses are called perceptual hypotheses. So most of this is unconscious. We're processing sensory information. And again, visual apparatus is what we're focusing on, but there's other senses, certainly, that provide us with information about the world out there. But these guesses, like an experimenter makes a guess about what the outcome of their study is going to be, we as information processing machines are in the business of making guesses about what image out there, what actual physical stimulus there is responsible for the excuse me, for the stimulation of our sense organs, and these guesses are called perceptual hypotheses. Excuse me. All right, so I want to illustrate how we're making guesses, and sometimes how our guesses can go wrong and can get kind of frustrating at times when we're trying to decide what's out there, but we can't really come to a satisfactory conclusion. So take a look at this image. This is one of the images produced by M.C. Escher, the famous artist. So I want to illustrate that as a whole it works, and then if we really sort of get in and parse this image and look at it bit by bit, then it will cease to work. By work, I mean if you look at it just on the face of it, if you look at it, it looks like a three-dimensional structure. It looks like a building with a waterfall built into it. But as we look at it more closely, that hypothesis will be proven incorrect. So let's do that. So here's a closer image of the structure. This is the waterfall. So let's take a little journey down this waterfall. Let's suppose we're on the top, and so we come down. We're flowing with the water, and I want you to notice where things start getting a little bit weird. So right now it may be working for you as a three-dimensional structure, a possible three-dimensional structure. Water flows down and then hits the wheel. It pushes the water back, and then we flow back. Maybe there's something getting weird for you now, for some of you, if you're noticing. And then we travel farther back, and I want to just stop here and look at this space here. And I want you to notice if anything's odd. Is this a possible three-dimensional structure? That is, could you actually realize this structure in a three-dimensional space, or is it some three-dimensional figure that's represented in a two-dimensional space that is actually not possible in an actual three-dimensional space? The answer is it's an impossible figure. This, if you actually tried to build this, it would look very, very strange. It wouldn't look functional as it does now in this two-dimensional space. So what Escher has done to create an impossible figure is to misapply cues to depth and create what's called stimulus ambiguity. And these are known as impossible figures because what we're doing is we're forming a perceptual hypothesis that it is a three-dimensional figure, possible three-dimensional figure rendered in a two-dimensional space, and artists do this all the time using cues to depth, like, for example, interposition. That is, these images are interposed. This one is overlapping with this one, and this gives the illusion of depth. And this is how artists, these are called pictorial cues, this is how artists create the illusion of three dimensions in a two-dimensional space. So this is interposed with this wall, which means that this is farther away. This wall is farther away from us than this, and so it gives us the illusion of three dimensions. So that works. That little part of it works. But as we travel back, we see this part here. What's going on here? A couple of different things. This column, Escher has used interposition to give the illusion of three dimensions. That is, this appears to be closer to us than the wall behind it. Also, the height in the plane is another cue to depth. This is higher in the plane than this, so it gives us the appearance that this is farther away than this. But as we travel back here, presumably at this point we're closer to this particular point than we are to this point up here. But when we get back here, these two positions are on the same plane. So what Escher is doing here is misapplying these cues to depth. He's essentially messing with our perceptual apparatus to create this ambiguity such that we cannot, in the end, decide what exactly it is that we're looking at. So in the end, what we're doing is forming perceptual hypotheses. We're making guesses about what exactly it is that we're looking at. And then we have to change our guess. We have to reconsider our initial hypotheses when we get to points where there's this stimulus ambiguity. And that's what makes these images somewhat uncomfortable to look at, because in the end we can't really decide what exactly it is that we're looking at. And in this way, Escher's images illustrate our process of forming these perceptual hypotheses. We want to be able to land as perceiving, acting, thinking, feeling creatures. We want to be able to decide with some degree of certainty what exactly it is that we're looking at. And these figures are impossible for us to arrive at some sort of satisfactory conclusion. So we're in the business of making these guesses. Most of the time, our guesses are pretty accurate. Otherwise, we wouldn't have lasted this long as a species. There are a number of different things that influence the accuracy of our guesses. Artists like Escher like to mess with this. They like to keep us guessing about what exactly it is that we're seeing. But generally speaking, just as a matter of getting along in the world in a way that works, we're pretty accurate. But there are a number of different things that factor into the accuracy of our perceptual hypotheses. So we're going to talk about each one of these in turn. So we're going to talk about how we process sensory information, perceptual learning. Some aspects of perception are learned. Our expectations about what we expect to see can influence what we actually see. Environmental cues, context, for example, the context in which we see things will influence what we see or what we guess that we're seeing, and then culture, our socialization, our environment that we grow up in can certainly influence what we perceive. All right, so let's look at processing of sensory information. So feature detection. In 1981, Hubel and Wiesel won the 1981 Nobel Prize in Physiology and Medicine for their research on feature detecting cells. And if you want, you can pause this video and go to the supplementary websites and watch the very short video that captures Hubel and Wiesel's research on cats. If you don't like cats, or if you like cats, you're not going to like the video, because what Hubel and Wiesel did was project electrodes into the visual cortex of cats' brains, and then they ran objects across the cat's visual field, and their idea was that they would capture the activity of these neurons that would fire when objects of particular configurations and shapes would be entered into the cat's visual field. And as you'll see in the video, what they found was that the cats certainly had specific cells in their visual cortex that were designed to respond selectively to objects that were of a particular configuration. And this was a really revolutionary finding, because what it suggests, and humans have these kind of cells as well, is that as information processors, our sensory apparatus are specifically designed to respond, to fire off a neural impulse when objects of particular shapes and configurations enter our visual fields. Just like rods and cones are designed to selectively respond to light of different wavelengths, we also have cells in our visual cortex, our visual apparatus, that respond to shapes. And these are known as feature detecting cells. And this led to the idea that we're processing sensory information, and again, we're talking just about the visual apparatus. And we process this information in a couple of different ways. Bottom up and top down. So bottom up processing occurs when we sense basic features of stimuli and then integrate them into a whole. So part of what we see involves looking at the discrete parts of objects, and then we sort of automatically assemble them into whole, and then we perceive the object as a whole. Whereas top-down processing is kind of the opposite of that, and it's largely based on preliminary learning. Top-down processing occurs when previous experience and expectations are used to recognize stimuli. So these are two different ways that we process sensory information. We're going to illustrate both of these here. So when you look at this image, what do you see? What do you see? So most of you, if you're familiar with your past experience, you've experienced elephants, pictures of elephants. Maybe some of you have seen elephants in the zoo and so forth, or maybe even in the wild if you've been to Africa. All right, so you won't see a bunch of discrete X's, but rather you'll perceive the whole, and it's in the shape or the form of an elephant. But suppose you had never seen an elephant before. What you would be seeing is a bunch of discrete little images, and you'd probably, you do this unconsciously, assemble those into some form, and then you develop a concept or a name for that form. So what we're talking about here are bottom-up and top-down processing. Bottom-up is when we assemble forms or objects by putting together the discrete components of those objects until we land on a whole. Whereas top-down is based on earlier experience, learning that we've done. All right, here's a concept check. So I want you to try to read this paragraph, and then determine whether reading is a top-down or a bottom-up form of information processing. So certainly this is a visual stimulus. So I'm going to read this. According to research at Cambridge University, it doesn't matter in what order the letters in a word are. The only important thing is that the first and last letter be at the right place. The rest can be a total mess, and you can still read it without a problem. This is because the human mind does not read every letter by itself, but the word as a whole. So is reading top down or bottom up? Well, if you can read this paragraph as I just did, then it's top down. That is, we've already learned how to read. If you've learned to read, if native English is your language, and you've learned to read, you've learned um, uh, first by learning the alphabet and putting the different letters together to form wholes. And as an adult reader, you don't need to parse every word into its discrete components and to support reading. All you need is the order and the context. So as adult readers, native English speakers and so forth, reading is top down. But if you've recently learned how to read English, or if you're currently learning how to read in English, it might be more of a bottom-up process. That is, you've got to learn your ABCs, and then you've got to assemble those letters into wholes, which are words. Often we learn to read by phonetically decoding a word, looking at the letter and knowing what the letter sounds like. And again, the sound of a letter will depend, or a combination of letters will depend on the context. So there's a lot of bottom-up learning that has to happen before we can process textual information in a top-down way. So is reading a top-down or bottom-up? Well, it depends on where you're at as a learner. Certainly as native English speakers, adults who've learned to read and can read fluently and so forth, reading is definitely a top-down. So the ability to read this paragraph reflects top-down processing. All right, so how we process information affects our perceptual hypotheses. Learning experiences that we've had also affects our perceptual hypotheses, that our ability to form accurate renderings of the world out there. So some of these perceptual constancies we've acquired through our experience in the world. So size constancy is one of these. That is, the perceived size of objects remain constant. That is, if you look at this image, the idea is that this guy back here is farther away than this girl, but he's not this tiny little guy, and he's not this very large girl, but rather he's just at a distance. Likewise, in this image, the idea would be to create the illusion of three dimensions, and then we'd decide, are these objects around the same size, and we'd conclude that they are. Or if we'd look at this object and then we'd move it farther back, does it actually grow smaller? The answer is no. Its size remains constant. So size constancy is something that we learn. It's not something that we're born with. And I remember as a child driving across bridges and looking out and looking at boats out on the water and thinking as a little child, oh, look at those little tiny boats out there. They look like toys. I'd like to play with them. And also kids, when they go on an airplane flight for the first time, if they're 6 years old or below, and they look down and they haven't learned perceptual constancies, it looks like as they look out of the plane, they look down, they can see all little tiny cars and little tiny houses and stuff like that. And they'll actually believe that those are tiny little houses and cars. But we know as adults that simply because we're at a distance to those objects doesn't mean that they're smaller. Actually, their size has remained constant. Likewise, we have shape constancy. That is, the perceived shape of objects remains constant. That is, in this door here, we can see it looks like a rectangular, and now it's looking more like a trapezoid as its position relative to us changes. The actual position of this image is changing on the retina, but that doesn't mean the actual shape is changing. The actual shape of the object remains constant. And that's something that's learned as well, shape constancy. So these perceptual constancies, having been learned, shape the accuracy of our perceptual hypotheses. So if you've not learned shape or size constancy, you're likely to make errors in perception. So consider this. Have you ever seen something that wasn't really there? Have you ever not seen something that really was there? And I've got my glasses here as an example. How many times have I lost my glasses? And I've asked my wife, have you seen my glasses? And she goes, yeah, they're right there on your face, or they're right there in front of you on your desk, or something like that. Why is it that we sometimes don't see things that are right in front of us? Why is it that we sometimes see things that aren't actually there? Right? What do you see? So take a good look at this and ask yourself what it is that you see. So if you're seeing a couple of different things, that's to be expected. This is an ambiguous image, and it's known as the wife and mother-in-law ambiguous image. There's two things that people see usually in this image. So here I'm going to take my cursor and outline one of the images that people see, and that is the image of a young woman wearing a hat, looking away from us. So here's the contour of her face, here's her nose, here's her eyelashes, here's her cheek and her jawline and her ear. And she's got some sort of choker on her neck here, some necklace or something like that. Here's the fringe of her dress. The other image is the mother-in-law, and this is derogatory, but that's the name of it. The mother-in-law here is, here's the outline, here's her forehead, and here's a bump that she has on her nose, and she's got a rather large nose. Here's her nostril, here's her upper lip. It's a pretty flat upper lip, and here's her thin mouth, and here's her jaw, her chin, and then I think I mentioned that this is her eye here, and this is her hair kind of coming down over her face. So that's the mother-in-law. So this is an ambiguous image. You could actually see two images if you think about it. In studies that have been done using these kind of ambiguous images, this one in particular, an interesting phenomenon occurs. That is, if you have a group of people, you divide that group into two different groups, and you prompt or prime one group to see the younger woman, and then you prime the other group to see the older woman, people will, in the end, see what they have been primed or prompted to see. So we could build an expectation that people will see a particular thing, and reliably they'll see what they expect to see. So this is the next bit about how different things influence our perceptual hypotheses. So we're going to be looking at expectations, and then also environmental cues that support our guessing about what's out there. So expectations we can think of as forming what's called a perceptual set, which is really a readiness to perceive a stimulus in a particular way. So in the experiments that have been done on that wife and mother-in-law, again, you lead people to believe that they're going to see a young woman looking away or an older woman looking down and towards them. Then people will reliably see what they've been primed or prompted, or what they expect to see. This is a perceptual set. It's a powerful, powerful means to impact perception. Marketing people and salespeople are well aware of this. So here's a research example of perceptual set. 60 people in turn were shown the same video clip on the same television. Half of them were told to expect a clearer, sharper picture thanks to high-definition technology. The other half were told to expect a normal image. So what do you What do you expect the outcome of this study was? Well, the results were that people who had been led to expect a high-def image reported seeing higher quality images. And this is, at least in part, how marketing people lead us to perceive that one product is better than the other, or maybe a product's been redesigned and re-released as being new and improved. But actually, the perception, the perceived difference is really just that. It's a perceived difference. It may be a not much of an actual difference at all, or maybe a difference certainly in the technology or so forth, but as perceivers the difference is so minuscule that unless there was in absence of all the marketing and the hype that goes along with the differences, we would not be able to detect a difference. And certainly if we're led to believe that there is a difference, then we'll probably perceive that difference reliably. By way of perceptual sets, our perceptual hypotheses are formed, and sometimes they can be accurate, and then other times they can be inaccurate. So a perceptual set implies that A, people often see what they expect to see. B, visual perception is based on a bottom-up processing strategy. C, the focused attention stage of processing is often overridden by the pre-attentive process. D, feature analysis is a hardwired process. A is the correct answer. People often see what they expect to see. All right, so environmental cues, again, we're talking about context and so forth. Other cues that affect our perceptual hypotheses, so context can affect perception. So if you look at these images, let's look at horizontally here, we have 12, 13, 14, and then vertically we have A, B, C. So it's the middle object here that can be either a letter or a number depending on the context in which we're perceiving it. Here's another example. So the cat. In the context of the letters T and E, this appears to be an H. In the context of the letters C and T, this appears to be an A. So context can influence perception. Here's another example of an image. So what do you see? All right, let's put it into context. And again, there's been studies that have put objects that seem to be somewhat ambiguous in different contexts, and people reliably report seeing different things. So here's a couple of different contexts. In the context of humans, this image that you just saw appears to be an old man, or seemingly an old man with a pair of spectacles on, whereas in the context of animals, it appears to be a mouse or rat. So context exerts a tremendous influence on our perception. What we see often is a function of the context in which that thing appears. Here's another example. These are optical illusions that are rather interesting. So here's the object of interest. This is the circle here that we see in the context of smaller circles, and then here we see the same image in the context of larger circles. So both of these images, these circles in the center, are the same exact size. However, which one appears to be larger? Well, the one on the left that has a smaller circle surround appears to be larger than the circle in the context of a larger surround. So this is an optical illusion. You can think of this as having a social perception parallel as well. So if you've heard the expression being a big fish in a small pond, well, this has to do with social perception. Sometimes we surround ourselves by people who may be smaller than us, either physically or maybe in a sense of status, social status, and that sort of thing. So the smaller the people are that we surround ourselves by, the bigger we feel. Likewise, if we surround ourselves with people who are more accomplished than we are, and that sort of thing, the context, social context changes, we might feel smaller, figuratively speaking, ourselves. So it works in visual perception, but it also works in social perception. Here's an example of context of color. So these two brown squares are the exact same hue. However, this image, because it has an orange surround or a lighter surround, appears to be darker than the brown surrounded by darker colors. So color perception is a function of context as well. This is why when you're designing buildings and so forth, the interiors and colors and that sort of thing. You have to be really careful about color selection and also the way that different colors work together, hue as well as brightness. All right, lastly, I want to look at culture just very briefly. So our socialization, our environment that we grow up in can certainly influence our visual perception in a number of different ways. Here's my example. I want you to consider what you see in this image. So just briefly consider what you see in this image. What are you looking at? All right, I just want to talk about this quickly. If you show this image to people that have grown up in the United States and sort of traditional Western industrialized nation, most people report that they see, of course, it's a group of people. If you ask those individuals whether they perceive those folks as sitting inside a room, most people will say, yeah, I perceive those people as sitting inside of a room. The cues, for example, that might lead somebody to form that perceptual hypotheses are this image up here. It looks like they're in a room with four walls. So people, for example, who grow up in New England are quite familiar with the interior of buildings. We spend a lot of our time, particularly in winter, inside of these four walls and so forth. This is another cue that might lead somebody to believe that they are inside or the interior of a building. This might be perceived as a window. However, when you show this image to people from other cultures, let's say Western Africa, they're more likely to perceive these people as sitting outside. And again, the difference between the cultures is pretty clear. That is, if you've been to a warm tropical climate, people are spending a heck of a lot more time outside, out of doors, than people are in New England, particularly in the wintertime when it's really cold. So so what are some cues that might lead somebody to believe that this is a family sitting outside, aside from growing up in a place where people are spending a lot of time outside? Well, this might be perceived by somebody from Western Africa or maybe Central America or South America, somewhere where it's tropical, as a palm tree. Here's a person with maybe something on their head. There's places in the world, lots of places where people routinely position things on their head. Maybe not when they're sitting down, but it's certainly possible that somebody could have something positioned on their head. I travel to Central America and I see it all the time. So the point here is this, that the cultural context in which we are socialized can influence our perception. And you'll read about some of the other ways that culture influences perception. Depth perception, for example, is something that is in part learned and that's in part influenced by the culture in which we're raised. So culture, again, can affect our perceptual hypotheses. So I want to finish by asking this question, what is reality? And we sort of decided that a simple answer to that question was it's the joint action. It's the end product of the joint action of sensation and perception. So our sensory apparatus detect what's out there. They put us in touch with the world out there. Then it's up to our perceptual apparatus to sort of organize and piece together that information so that we get what we hope is a pretty accurate rendering of what's out there. Because really, we depend very heavily on our perception, our perceptual processes to give us accurate, to make our guesses very accurate, because it's those guesses that we end up operating on. We shape our behavior, our thoughts, and our emotions based on our perceptions. So here's a segment from a Buddhist quote that I think is appropriate. We are what we think. All that we are arises with our thoughts. With our thoughts, we make the world. So the power of perception and perceptual hypotheses. But I want to add into this, because context and environment and culture and so forth factor into our perception, shape our thoughts, shape our emotions, shape our behavior. Our world, to a large extent, makes our thoughts. Here are the learning objectives. Please attend to them. I want to draw your attention to the red font objective. Be sure you read in the text about the monocular and binocular cues employed in depth perception, because we didn't talk about these in lecture.